Okay, we're continuing on bonding, and we're going to be talking about molecular shapes. Okay, and two things really go into determining what a molecule has as a shape, and that is going to be electron domains, sometimes called charge centers, and also the atoms, okay, well, I should say atoms bonded to the central atom. Okay, so you really identify what atom that you're going to be talking about the shape, and then you look at the electron domains around it to determine how they repel each other, and then you look at the atoms attached to actually determine the molecular shape. Okay, so let's define electron domains or charge centers. These are single bonds, double bonds, or triple bonds. All count as one electron domain. Okay, also lone pairs are an electron domain. And the idea is that these will repel each other and get as far away from each other as they can. Okay, so the other thing to note is that a lone pair of electrons will have a greater repulsive force. Okay. All of this falls under what is known as Vesper Theory. That's valence, shell, electron, pair, repulsion, theory. All right, so let's look at something that has two electron domains. This will be something like carbon dioxide. Carbon making two bonds, or double bonds with each oxygen. Okay, that would be the Lewis structure. If you look at the electron domains that around carbon, it has this electron domain and it has that electron domain. They will be 180 degrees from each other, making this linear because there is a molecule on both sides of those electron domains. Okay. If I have three electron domains, this could be something like BF3, violates the octet rule. I have fluorine, fluorine, fluorine. Don't forget the unshared pairs on the fluorine. Okay, looking at the electron domains, you can see that there are three of them. All right, so each of these will be 120 degrees apart. Okay, they will all be in the same plane. Right? So for BF3, because I have those three atoms attached, okay, you look at the atoms attached to each other. If I have three electron domains with three things attached, this would be a trigonal planar. Oh geez, I can't spell. Trigonal planar. If I have something like ozone, ozone has a double bond, single bond, this, 1, 2, 3. Again, it's got the three electron domains. Remember, lone pairs count, but it only has two atoms attached. So this would be bent. And because this lone pair has a greater repulsive theory, this angle here is going to be something less than 120. You don't need to know exactly what that is, just that it will be less than 120, because that lone pair pushes those down farther. Okay. The next thing we're going to talk about has 4 electron domains. And remember, this has to be 3D. So this is a tetrahedral shape, something like CH4. H, and then goes behind, and then 1 comes out. All right, and that is tetrahedral. Something like this would have 109.5 degrees between the atoms. If I only have 3 things attached to that, like NH3, I have N, H, H. That's supposed to be coming out at you. I'm trying to draw it 3D, and going away from you. This would be trigonal pyramidal. Wow, I can't spell today. Pyramidal. And I don't think there's an I in there. Oh dear. And because of this lone pair, it pushes those farther off the plane, and it would typically have something like 107 degrees. All right. And then we have water. Okay, with the 2 lone pairs. This would again be bent, and it would be 104 degrees between the 2 hydrogens. All right. Okay. So those are really the structures that are going to obey the octet rule. Fairly quickly, we're going to go through expanding the octet. These, I think, are easier to see in 3D, so please ask me in class. I will be more than happy to build them, or hopefully I'll have them already done. So if I have something with 5 electron domains, if I also have 5 atoms attached to those as bonds, I will have a trigonal bipyramidal. Now I can spell. If I only have 4, it will have a seesaw shape. If I have 3, it is a T-shaped because literally it looks like a T. And if there's only 2, it is going to be linear. Now if I were to draw what the structure looked like, I would have my center atom here. I would have 3 electron clouds on the same plane, and then 2 on the axial. All right. Hopefully, they call it trigonal bipyramidal because you really have a pyramid forming from that one axial electron domain and then one on the bottom. Seesaw is when I have here, 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 and here. And then hopefully you can say T-shaped is I would take away that one. Right? Again, I think they're easier to see, but the ones on the equatorial plane are the ones that are going to be taken off first, if you want to view it that way. Okay, and then the last shape for us to talk about, or the last kind of electron domain, is something that has 6 electron domains. This is your octahedral. Oh, you know what I forgot? Sorry, let's go back for just a second. The angles here, you have 90-degree angles, you have 120-degree angles, and if you have T-shape or seesaw, you will have 180-degree. octahedral, we have 6 electron domains. So we have 1, if this is your center atom, and then we have 4 on the same plane. Okay, if I have all 6, obviously it's an octahedral. I can have something called a square pyramidal, or something called a square planar. These are basically 90-degree angles. Okay, and that ends the screencast on shapes.